All right.
Okay.
Go ahead.
Hi, everyone. Today, Emir Demiral from Queen Mary and I from JKU will present you our topic that we have started at the Sandbox event in London, titled Real-Time Recitatives to Score Alignment. Yes, this task is inside a more general task called opera tracking, which aims at doing real-time audio-to-audio alignment between two performances, one used as a reference and one used as a target that we want to align. And opera tracking aims at retrieving the current score position through time. Recitatives are an important part in opera. They are the heart of the opera, and they allow a fast progression in the story, and they emphasize the text content and not the accompaniment. A nice definition of the recitative is that it is a rhythmically free vocal style that imitates the natural inflections of speech. If you apply the state-of-the-art methods of opera tracking on Don Giovanni performance, which involves like a performance to reference alignment method, there is a weak accuracy on recitatives. As you can see in the table, and if you use a threshold of 1 second, you can see that the state-of-the-art method is allowed to detect around 90% of the bars below an error of 1 second. But if you limitate the dataset of just the recitatives, it drops to 66%. Of course, inside recitatives, there are many challenges, such as the acoustic conditions, where the voice quality is altered during the actor's movement on the stage. Also, the singing voice is acted, so it can be whispered, spoken, or sung. And the accompaniment is improvised and played by different instruments. I wanted to show you an example. It's the beginning of the Act 2, Scene 2 of Don Giovanni by Mozart. You can see on the right the screenshot of the score, where I added some markers in blue referring to Karajan performance and in red of Fischer performance, where the accompaniment decides to play the chord. Let's listen at Karajan.
Amico, che ti pare? Mi par che abbiate un'anima di bronzo. Va là, che sei grandonzo. Ascolta bene. Quando costei qui viene, tu corri ad abbracciarla.
Okay, and let's listen to Fischer now.
Amico, che ti pare? Mi par che abbiate un'anima di bronzo. Va là, che sei grandonzo. Ascolta bene. Quando costei qui viene, tu corri ad abbracciarla.
Okay, thank you, Charles, for your detailed introduction of the project. So in addition to what Charles mentioned about the differences in different performances of the same composition, there are many musical aspects that change as well. In this slide, we see two different excerpts of two different performances of the same singing the same score in the which is shown below. From the green lines, which are the pitch tracks, we can see the pitch tracks are different. So let's listen to these samples first.
Row, row, row your boat.
And the other one.
Row, row, row your boat.
So as we have heard, the tempo changes, the pace changes, the prosody changes, the pitch track changes, the genders are different, and even the acoustic conditions may be different. But we know that the linguistic content or the lyrics stay the same. That's why we have taken the strategy to align the reference and the target recordings based on their linguistic content, as it stays the same in the both recordings. To do that, we use the acoustic model of a pre-trained, powerful automatic voice transcription system. And then using this acoustic model, we apply forced alignment to obtain timestamps of the words from the reference recording. To mention, forced alignment is the process of finding the best path in a signal given its acoustic observations. So in this case, our sequence will be the word sequences. So once we obtain the word and timestamp pairs for the reference audio, we apply the same for the target recording. And we obtain the same word timestamp pairs for the target recording as well. Since the word sequences are the same for both of the recordings, when we obtain the timestamps of these words in the audio signal, we automatically obtain the positions in the score, in the reference score. So that is the main idea of the strategy, the approach that we are proposing in this project. To train our acoustic model, we have used the combination of 3 Italian corpora. The first one is called MLS-PKA, which is an 2 hours of corpus curated for phoneme recognition purposes. We also use the Italian subset of the common voice corpus released by Mozilla. And so these are speech data. In order to add some singing data in our training data set, we add the Italian subset of the DAMP repository, which is released by the SMIL. Once we train this acoustic model, we test the performance of the word recognition on 2 different performances of the Don Giovanni, Mozart's Don Giovanni composition, conducted by 2 different conductors. So far, we were able to construct a system using the training dataset that we have created. And we have assembled and extended a pronunciation dictionary for Italian, which is a core element for the automatic lyrics transcription system that we are using. Even though we are not able to achieve robust word transcriptions for opera singing in Italian, we were able to achieve good phoneme level alignments, though it is offline. So let me show you one example, one small demonstration of it. So can we see the sonic visualizer interface? Okay, so I slowed down the recording a little bit. So in these segments, we see the phonemes of the recording aligned automatically on time. And note that we are not using any ground truth here, so the alignment is performed on the whole audio. So let's listen to that. Okay, so I think that's enough to have an idea of how the system works at this moment. So, okay. Are we in the slides again? Can you see me?
Yeah.
Okay. Okay. So the thing is, this forced alignment is performing in an offline fashion, and in our project, our main target is to achieve that in real time. So that remains as a challenge, as a bottleneck. To apply this online alignment, we need a robust word recognition system. And for that, consequently, we need lots of training data that can generalize the system for opera recordings.
Yes, and of course, by training data, maybe we need also like opera training data, which is a lake of available data. So we plan to do annotations on opera recordings at the sentence level to get more data, training data. We also want to compare this method that we presented to another one involving GTW-based alignment with recitative specific features. And as a long plan, we hope that this work will be a way of publishing this new recitative to lyric alignment method further during the year. Thank you.
Thank you.